Hello to all my lovely Form 3 ladies. Today's session is all about angles of elevation. So in this session, we're going to look at solving problems involving angles of elevation. Hope you remember how to do your tricks and use your calculator because you're going to need those skills. Get your pens, pencils, erasers, and rulers ready. We have some diagrams to draw when we work on these problems. Now, when we deal with problems involving angles of elevation and depression, it is highly recommended that you draw a diagram, especially if you want to get that visual perspective on what the problem entails, because that way you have a better chance of identifying whether or not you're dealing with an angle of elevation or depression, and you get that visual perspective as well of your information. So we're going to look at the first one. So they say that Brian's kite is flying above a field at the end of 65 meters of string. If the angle of elevation, so they technically give us this right away. So if the angle of elevation to the kite measures 70 degrees, how high is the kite above Brian's head? So let's take it piece by piece. We know we're dealing with an angle of elevation, all right? Let's start doodling. So here we go. Let's start with the angle of elevation. So first of all, we have to assume this horizontal line of sight. And the horizontal line of sight will form with where Brian is at. So I'm not going to draw in like his height or anything. I'm just going to draw the line of sight. I tried, okay. Anyway, the point is this should be the horizontal line of sight. That will be from his vision, right? His line of sight. Now the kite, they're saying, is flying above a field at the end of 65 meters of string. So my question to you is this. When you're flying a kite, you'll ever flew a kite before? Yes. Let's say you are standing here, right? So I'm gonna make a blue dot for where Brian is standing. So this blue dot here, this is Brian is at. My question about this piece now, how would the line for representing the 65 meters of string for the kite be represented? Would be represented
Up.
It'll be up, going
Upwards.
so we'll be going upwards. We're going upwards from the blue point from the horizontal line, like so.
Yeah.
Or we all right. So yes, the reason I'm asking this part of things, we needed to form the angle of elevation. And the only two lines which could form the angle of elevation for us would be the line of sight, the horizontal line of sight, not so straight, and then the line which would represent where the kite is being tethered, the string, all right? So my angle of elevation of 70 degrees, although this doesn't look accurately like a 70-degree angle, this is where it will form. So I'll just insert that, 70 degrees. Now, to solve angles of elevation and depression problems, what type of shape you think you're going to form here?
Triangle.
A triangle. Exactly, a right angle triangle. There we go. I'm going to attempt to draw a kite. What color we should put the kite in? So let's label the information. So the one thing we've labeled so far is our angle of elevation, 70 degrees. What did they tell us about the string?
65 meters.
Very good. It's 65 meters. So we're going to label this length, which represents the length of string, as 65 meters. So let's continue from here now. I know that I'm dealing with a right angle triangle. I have an elevation angle labeled. I also have a length labeled. If I want to solve for the height, they're asking, this is a question, right? How high is the kite above his head? So basically the height that we're looking at is this horizontal height here, right? How are we going to find that height? Anybody?
We have to label the diagram to find out what trig function we'll be using.
Good. So let's go. Let's label the sides. Anybody? Which sides do we know?
5 meter is the hypotenuse.
Very good. This is our hypotenuse.
And the right angle box to the kite dot is the opposite, side opposite.
Lovely. So this is our opposite side.
And the line with the angle on is the adjacent.
Good. So now that we know which side is where, let's talk. Which side do I want to find?
The opposite.
The opposite. So which trig function should we use?
Sine. Sine.
Sine. That's it. Sine. So everybody agrees, everybody understands how we're using sine, why we're using sine.
Yes, miss.
Yes?
Not really.
Okay, good. Just want to make sure. Right. So I'm going to write now sine. So somebody just said sine theta. In our case here, we have the angle 70 degrees, right?
70 degrees.
Very good. So sine 70 is equal to our opposite side, which we don't know just yet.
Over the hypotenuse.
Very good. Over our hypotenuse. So I'm going to substitute my hypotenuse length now. Now, if I have to solve for the opposite, anybody want to tell me what would be in my next line? What would I write after? Opposite is equal to?
Sine 70 degrees multiplied by 65 meters.
Very good. Right? So go to your calculators now. Remember, well, this is multiplication. So if you are entering your trig function, just remember, be particular about the order in which you type stuff. Use brackets if you need to. All right, so anybody want to share with me what they got for their answer?
61.080.
Very good. 61.080. If we go to 3 decimal places.
If you know how to type it into the calculator.
Okay, just now I'll share my calculator in a little bit and show you all just in case, right? So yeah, the exact, well, not so exact, but the exact figure to 3 decimal places was 61.080. So if I decide to go to the nearest meter, I would just write 61 meters. So let's talk about calculator part of things now. The order I wanted to specify, right? So if you're using a scientific calculator, use brackets just in case of anything. So for instance, Talisha was just pointing out that when she did hers, because she didn't close off her bracket, she got a completely different answer. So entering your information, what you want to do, for me, I put 65 multiplied by open bracket. Then because of the calculator on my computer, how it does it, I have to enter the angle first. I open the bracket, enter the angle, then press my trig function, and then close the bracket and press equal. Now, some people, if you're using a scientific calculator, you'll be able to just enter the problem exactly as it is written. Oh, look at that. Somebody got it. So you can enter the way you did just now, which is, notice she put sine 70 multiplied by 65. So you can enter it like that as well, because multiplication is commutative, so it doesn't matter the order in which you perform your multiplication. But when it comes down to functions, make sure, in particular, when you're dealing with the trig functions, your trig function, you put your angle in brackets, especially with like the online calculators, the calculators on your computer, you have to put the brackets. But on your scientific calculator, you can just put the trig function and then enter your angle, and it works out just fine. And just a quick reminder, in case anybody did not get the answer we got, and they're probably wondering how come, double check, like we were just saying, double check that you've closed brackets if you used any. Double check the order in which you entered your information. And also, for those of us using scientific calculators, double check to make sure it is in degree mode and not radian or gradian. So make sure you see DEG. If you don't see DEG, you should have a button that allows you to move between degree, radian, and gradian. So you press that button until you see DEG. And this is also applicable to your mobile devices, scientific calculators there. All right. So back to our angles of elevation and depression problems. Once we all understood how to identify the trig ratio involved to solve this one, and we were able to use our calculators with ease, we would all get the same answer. Now that was a nice session, wasn't it? If you thoroughly enjoyed learning how to solve problems involving angles of elevation, feel free to move forward to our next session when we do angles of depression. Now, if you would like to do some review on some of the previous topics, maybe you should check out this math playlist. Never miss another video. Be sure to subscribe so you're always going to be up to date with all my content. Thank you very much for watching.